Good afternoon, everyone. Let's get started. Today, we're going to talk about arrays and strings. First, course logistics, and then I'm going to introduce what arrays and strings are, and then I'm going to summarize this lecture. First, course logistics. Homework 3 is out today, and it is due next Thursday. All right, and then I'm going to introduce arrays and strings. First of all, let's talk about the definition of arrays. So what are arrays? Basically, an array stores a list of items. In other languages such as Java, C, or C++, the only built-in method of storing collections of objects. If you need anything more sophisticated, you need to use a data structure from a library. For instance, if you're using C++, you need to include list library to use a good array that offers a variety of functions. On the other hand, in Python, lists are a basic data structure. But of course, the Python interpreter has implemented it with an array in advance. That's why we can use lists without importing any libraries. And let's talk about the array ADT, abstract data type. So this is an abstract definition of what array needs to support and what array can do. An array is a block of memory. And we store some items, and here I'm calling those items a fixed number of objects. And here you need to be cautious about this word, fixed. You cannot possibly resize the memory block. Once you assign some memory block to an array, then you cannot change the size. So the array size remains fixed once the array has been created. You cannot change the size. However, in Python, we can change the size of the array, and I'm going to show you in the implementation session how we can do that. However, basically, an array in other languages like C or C++, Java, you cannot change the size of an array. Once you define it, it's fixed. And in fact, that is same for Python. However, we are offering some new functionalities where we can change the size of an array. And the functionality of an array, first of all, we need to be able to create an array with n slots using array n. This means we first need to specify how much memory space we are going to use for this array. And we can get the length of an array with this len function or len method. And we can access or modify, of course, we need to be able to do this, the element at index I with this operation, a bracket I. And because an array contains a number of items, we need to be able to loop over the elements of an array. All right, let's implement. So we're going to implement these 4 functionalities. And this is our Python. We are going to start with a basic array simulation. Because we already have a list, because we can define a list without importing anything, we're going to just simulate an array in this class. Let's first define the array class. And before we start implementing this class, let's first write some test codes, what we want to do with this array class. I told you that we need to be able to define an array. And the parameter we are going to pass is the number of or the size of memory block we are going to use with this array. And I told you that we need to be able to assign some values to this array like this. Let's do another one. So we could change the content at the index 0 as 5 and at fifth index as EC2202. And we need to be able to access to items at specified index. So for example, test array third one will print out none. So from this, you could figure out that if we do not assign any values, specific values to specific indices like this, then the default value this array contains is none. Okay. And we could also print the array like this. Then what we want to do, what we want to get is, because we assigned 5 to the 0th index, the first element is going to be 5. And because we haven't specified other items, they are going to be just none. So for none, and then EC2202, and another none. And the last thing we want to do is iteration. We would like to iterate through the items inside this array as we did for other lists, sets, and dictionaries. This is very important. So we need to be able to print item inside this array like this. And it is going to print out the items stored in this array in sequence. So none, EC2202, like this. Okay, so this is the functionalities we would like to implement for an array. Are there any questions up to this point? Cool, let's move on. First things first, we need to implement a constructor. And I told you that an array at the construction stage receives the size of memory. So here we're going to receive this size parameter. And in the last class, we talked about error handling. In this case, I'm going to introduce another functionality of Python, that is assert. This one assures that size should be larger than 0. Otherwise, it's going to print out this error message. Okay, so this is a very simple way to check or assure that size should be larger than 0. Okay, and we're going to set the size of this array as size. And we need to also store the elements. And I told you that if we do not specify the elements as specific indices, then the default item this array is going to store is none. So we are going to store none. And the number of nones is going to be size. And let's check this one first. I would like to create an array. And if I pass -10, it's going to cause an assertion error. It says array size must be larger than 0. So if this condition does not meet, then this error message will print it out. Okay, so that is the functionality of assert. And if you pass positive number, it works perfectly like this. So here, assert is to check whether the given value is in the correct boundary or not. The next thing we're going to implement is len method. If you implement this len method, then when this len function receives some object, it will call this len method and returns the length of the result of executing this method. So this is to support this len operation. And the length is quite easy. We just need to return the class or instance attribute like this. So up to this point, we have implemented this constructor and the second functionality where we can get the length of an array. And the third thing we're going to implement is accessing or modifying the elements at index I with this operation, a bracket index. And to implement that, there is a special method offered by Python that is getItem. If you implement this method, then you can get the item at index I with this method. So when you call this expression is bound to this method, and this method will execute this default method and returns the result of executing this method. And when we try to get an item at index I, this should be in the correct boundary as well. So we are going to assert I should be larger than or equal to 0, and I should be smaller than the length of self. Otherwise, you are going to print out an error that array index out of boundary, like this. Otherwise, we can return the item at the index I, like this. Okay. And let's check this functionality together. So here, we're defining an array. The next thing we also need to define is set item. Here we need to specify two things. We need to specify the index where we want to set an item and the item v. Here v is actually valued. Anyway, if you call this expression, it will be bound to this set method and returns the result of executing this set item method. And we need to do the same thing as we did for get item to set an item, because the index should be in the correct boundary. Otherwise, you are going to set an element or item at index I, like this. Okay. Let's check our implementation. First, I'm going to set an item at index 0 and set an item at index 5 as EC2202 And I'm going to print test array 0 and 5. And when I execute this, we successfully assign 5 to index 0 and EC22 to index 5. And when I try to print out other values at different indices, it's going to be none. So up to this point, we have implemented these three functionalities. And I would like to implement the last operation, iteration. However, before we do that, let's print the test array itself. When we try to print out the test array, it says it is just an array object. And in the last class, we talked about this. What kind of method do we need to implement to support this functionality? So when we try to print this test array, we want to print out this kind of expression rather than this address expression. So which method do we need to implement to support this functionality? Yeah, we need to define stir. Thank you for your answers. So this is our first TPP exercise. Try to implement this stir method on your own. And before you start to implement this functionality, please send me a PPP message. I'll give you like 2 minutes. I'll give it 30 more seconds. All right, let's implement this functionality together. This is the form we want to print out. And let's see how we can do this. There are two ways to implement this functionality, in fact, and let's see both of them together. First, because the results should contain this array and opening parentheses, we're going to start by creating this opening string. And for items inside our elements, what we are going to do is we're going to add some strings after this. However, we are not sure if this could be added to this string or not. So we're going to call this stir function and then change the elements at index I as string. Okay. However, we also need to be careful about adding this comma and space. So what we're going to do is add separator like this, and the separator is going to be comma and space. And after adding all the items, we need to close the parentheses. So we're going to close the closing parentheses like this. And Hein pointed out that we need to specify separator first. That is correct. So we need to define separator here. And the first separator we are going to use is just a blank. Because when we are adding the first element, there should be nothing. However, if we're adding the second element, there should be comma and space. So here, comma and space comes. And after this, we're going to return the string. So, is it understandable? And another way of implementing this functionality with one line of code is by using the map function we used. So what we can do is there are some special function provided by the string object, that is join. So if you join some elements with this string, then all the elements inside this join function will get joined, separated by this separator. And before we do that, we need to convert each item inside self elements as string. So we are going to map string to our elements. like this. And then we need to close this expression with closing parentheses. So both are okay. This one is more intuitive and straightforward implementation. And this one is a Pythonic implementation. So both are okay. So if you're not sure about this join, I'm going to show you what join is. So we need to map star to this list. So the items inside this join list is concatenated by this separator. So you can implement this block of code with just one line. All right. So let's check our implementation. So here, when we try to print our test array, it successfully print the array in this way. And so to this point, is there any question? Okay, the last thing we need to implement is iterator. In other languages like C++ or Java, there is an explicit functionality called iterator, and that is very important. And that is the same for Python. However, it is out of scope of this course, I guess. So I'm just going to show you one example implementation of this iterator. And you don't have to worry about this. This will not be on the exam. I'm just showing you how you can implement this, but don't worry too much about this. To implement an iterator, you need to define another array iterator class like this. And this one receives the elements and determines how to pass the next item. So when you implement this next method, it determines what item to return the next time. And I told you that this will not be on the exam, so don't worry too much about this. Okay, let's move on. One problem of this array is that it has fixed size. And in Python, what we usually do is we can append new items in this way. So firstly, we assigned just 5 slots. However, we can add one more slot. And we would like to support this functionality. And that is the next topic of today's lecture. Arrays that can grow. This is the next thing we would like to implement. Let's define the class grow array. And I'm going to copy these codes and modify some of it. How should we modify the constructor? Because this array can grow, we don't have to specify the size. So we don't have this assert expression. And what we are going to do is we're just going to have an internal list that is nothing, none. So this means this array starts from 0 length and then grow. This is what we are going to implement. And how should we modify this len method? We do not know the size. We don't have this attribute. So we are just going to check the length of the internal list like this and check the length when this len function method is called. And get item needs to be just passing, returning the item at index I after checking the index like this, okay? And you're not going to perform set item and stir thing, or rather, here we are going to support this append functionality. So when we're given new element, we need to add this item at the end of the current list, current array. And when we're doing this, we need to think about two cases. The first case is there is nothing inside. So the length is currently 0. In this case, if self array is none, then what we need to do is define a array with size 1, and we're going to assign this element to the 0th index like this. So this grow array is somewhat different from array, and we're just using the default array we implemented here. Okay, so we're using this array to implement an array that can grow. So we are implementing this grow array based on simple array. And the second case we need to think about is there is already some items inside. This is the second case. And what we need to do is, first, we need to keep track of the old items. So we are assigning this old list to old A. And we need to check the length of old A. And because there is one new item, we need to assign one more space like this. And then what we are going to do is copy all the items back and append the new item element. To do this, what we are going to do is to this new item, to this new list, we are going to assign old values like this. And after doing this, we're going to append this new item, L, at the end. So this is how we can implement this append method. Are there any questions up to this point? So to recap, to implement this append functionality, we need to think about two cases. The first case is there is nothing inside and there is no item at all. In that case, this is when internal array is none. Then we're going to create an array with size 1, and we're going to add this item at the 0th index. And if there are some items inside, then we're going to copy this array and then create a new array with bigger size like this, and then copy back all the old items back to new list, and then append the last item, new item at the last position. Okay. And let's check our implementation and how good it is. But before we do that, I would like to introduce one cool function feature of Google Colab. That is, we can read some files inside our Google Drive. So in my Google Drive, there is a Word 5000 text, and I'm going to read this text file and test how good our grow array can perform. So this is the path. And to do that, we need to mount our Google Drive to this Colab. And when we run this, this message appears when you just click this connect. And now Google Drive is connected to this Colab, and I can read the file. It takes for a while. And opening a file in Python is very easy. You just need to call this open function and specify the path of the file. And the path of the file is content drive. Here, the path is my drive and 수업 자료, EC2202, and lecture slides. And that is this path. And the file name is words 5000 text. And the next, so this is the path to the file that I want to open. And this R specifies that I would like to read this file. If you want to write some content to this file, you pass W rather than R. All right. And I successfully read the file. And I'm going to check how fast our row array can work. And I'm going to read, so the file looks like this. It contains some vocabularies starting from A to Z. So basically it contains 5000 words. And I'm going to read all the words inside this file and then store them into our grow array. So that's basically what I'm going to do. And I'm going to check how much time it takes to read all the items inside this file. And for line in f.read lines. So after you open this text file, you call this read lines method, then it will return each line one by one. And I'm going to just get this line. And this line is just a string. And I'm going to strip all the blanks. And I'm going to append the red word into this words list. And I'm going to check the time once again and print out I read all the words inside this file F, and then I'm going to print out the time it takes. And when I run this, it takes quite a long time. So it took about 9 seconds. And let's see what happens if you use just the default. So this is basically the same functionality. However, rather than using grow array here, we're going to use the default list offered by Python. Then this is the same code. It takes much less time than our grow array list. And can you guys guess why is our grow array so slow? Jaeyoon gave me this suggestion that when we try to append a new item, we need to create new array all the times. That is correct. And another suggestion was when we try to enter a new item or append new item, we need to access to the class again and again. That's also correct. And how can you improve this functionality? And another question that I would like to ask is what is the time complexity of our grow array? In fact, the append method. What is the time complexity of append method when we try to append n items? Okay, thank you for your feedback. Let's analyze the time complexity of append method together. You just look at the right side. All right, let's check this together. So the time complexity of this append is can be evaluated by evaluating this expression. When we try to append n items, then we need to assign n new operations. So let's talk about by changing k from 0 to n minus 1. So when we start from, let's say, 5 items, so we try to store 5 items, then what we need to do is we first need to create an array with size 1. And next time, we need to create an array with size 2 and assign 1 and 2 items. And next time, we need to create an array of size 3, and we need to repeat this process once again, 1, 2, and then we can add the third item like this. And when we try to append the fourth item, we need to create a new item, new array with the size of 4, and then we need to repeat this process once again, 1, 2, 3, 4. So when we try to add n items to our grow array list, what we need to do is repeat this process again and again. So when k was 0, we need to repeat that process 1. And when k is 5, we need to repeat that process n minus 5. Okay, so we need to repeat this creating array, new array, and deleting new array this time. And this is equal to n times n minus 1 over 2. And this one is approximately n squared. So the time complexity of this append method is n squared. And how can you improve this implementation? The basic idea is rather than creating new array again and again, we are going to initialize this array with some space like this. And we are just defining this size array once again. And here we keep track of the number of items using this size attribute. And the len method should be this one, modified as this one. And get item, similar to this one. And how should it change this append method? We don't have to think about the first case because we have already created an array with some space. So we're just removing the first case. We only have the second case. And rather than just assigning or creating new array, we need to check whether our internal array is full or not. So if the size of our array, internal array, is the same as the internal array, that means our internal list is full. In this case, we need to do this job, creating a new array like this. So basically, these functionalities are the same. However, what we are going to do is, rather than creating one more size, we are going to assign 32 size in this case, and copy old items back to the new item, and assign the new item at the end, and we need to increment the size by 1. So this is the modification of our implementation. And let's check how much better this implementation, this improved version can work. When we run this code again, sorry for that, local variable and reference before assignment. So I can change this one as self size, like this. And it takes much less time than our previous one. However, this one is still far slower than the default Python list. We can do better than this. An improved version, even better than this one, is rather than just assigning 32 more spaces, we can actually double the size in this way. Then the speed will be much, much faster. And let's check our implementation. So when we do this, it becomes much faster. And think about the time complexity of this one and this one. All right. Okay, so that was about arrays. So are there any questions up to this point? Okay, let's move on. So today, the topic of today's lecture is arrays and strings. So up to this point, we discussed what arrays are and how we can implement arrays. And let's talk about strings together. In Python, you can consider strings as a list. So when we are given, let's say when we are given this string, then we can just regard this string as a list. So we can access to the items at different indices like this. And we can change the item in index 0 as capital H like this. Assignment is not supported. Anyway. So basically you can consider string as an array, all right? So that is all we need to discuss about strings. So you just think of it as an array. And from now on, I would like to give you some PPP exercises. The first PPP exercise that I like to give you today is replace elements. In fact, this one is from Amazon coding test, coding interview. What we want to do is replace elements in this array. And what we want to do is replace every element in the array with the greatest element among the elements to its right. So it means 17 should be changed to 18 because among all the numbers on its right, the largest is 18. So it is changed to 18. And when it comes to 18, the largest element on its right side is 6. So it's going to be changed to 6. And this one, when we check this one, the biggest number on its right is 6. So it's going to be changed to 6 again. This one 6 as well. And for this one, the largest one is 1. So it is changed to 1. And we are going to replace the last element with -1. So last item is going to be -1. And if we have a list with a length of 1, then it is simply changed to -1. All right. So before you start to solve this problem, please send me PPP message. All right, let's thank you for your answers. Let's implement this together. So basically, this one is from Hong은. We can implement this one as like this. So we are going to iterate through all the items inside this list. And we're going to change the item at index I as the maximum value that are left on the right side. So these ones, I plus 1, and colon means all the items on the right side. You're going to choose the maximum value like this. And after this, we are going to assign -1 to the last item. And we don't have to return anything because when we do this one changes the items inside this array. And this is a very good implementation. However, this one takes O and square time complexity because we need to iterate through all the items plus this maximum value needs to check all the items on its right side over and over. So it takes another time complexity of O(n). And this for loop takes time complexity of O(n), and combined together, it takes time complexity of n cube. And there are another way we can improve the time complexity of this function. In fact, we can do this in time complexity of O(n). Okay, think about it on your own, and I'm going to let you know how you can solve this problem in time complexity of O(n) in the next class. All right, thank you for your answers. And the next question that I would like to give you is remove duplicates from strings. Basically, what we want to do is travel all over the strings like this, and we're going to remove all the duplicate items. So here V appears twice, so we're going to remove one V. So the result is going to be ZVO. And when you look at this one, we're going to remove, we have two G's like this, and we're going to remove the second G. So there is going to be no duplicate. And try to implement this functionality in time complexity of O(n) cube. Before you start to implement this function, please send me PPP message. All right, thank you for sharing your answers. Let's implement this problem together. In fact, this one is from Hey. First, we are going to define a blank string using this expression. And we're going to iterate through the string. And if this S is inside this mem, we're just going to continue. However, if this S is not in M, we are going to add this S to mem. And after finishing iteration, we're going to return this mem. And another thing you can do is you can just check if S is not in M, you can add this value to S. If S is not in M, you can add S to M, mem, like this. So both are okay. All right. Any questions about this implementation? Okay. And the last PPP problem that I would like to give you today. Sorry for this. The last problem I'd like to give you is print spiral. I'm going to give you some examples. So what we want to do is we're going to receive a 2D array. So 2D array looks like this. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And when we call this spiral array onto this matrix, it's going to print out the numbers inside this 2D array in this spiral order. So what I mean by this is we're going to print out the first row to get first 1, 2, 3, 4. And then rather than going to the next row, it's going to vertically down. So it's going to print out 4, 8, 12. And then it's going to return back to the first position, 11, 10, 9, and then go up 5, 6, 7. So it prints out all the numbers in this spiral order like this. So when you are given this 2D array, try to implement this spiral array that prints out the numbers or items inside this 2D matrix in this spiral order. As usual, please send me PPP message before you start to implement this function. I guess we are running out of time. I'm going to solve this problem in the next lecture. If you want to stick around here, you can solve this problem and discuss your answers with me. Otherwise, you can leave now. Thank you for your participation.